So last time we just finished up with this working with radicals, and now we're going to talk about roots and radicals and rational expressions, and that's lesson 17. In this lesson, we examine the relationship between radicals and exponential notation. In the previous lesson, the one we just did earlier today, we saw this example for simplifying the cube root of x to the 21st. We wanted to rewrite x to the 21st as some stuff to the third, right? Because then we could cancel the cube root and the cubed. So this is one of our new properties. And we just got x to the 7th. And I said, hey, you know, don't use a shortcut, but we saw what the shortcut was. What can we do with 21 and 3? We divide them, right? 21 divided by 3 gives you the 7. That's the answer up there. So we're going to fill in the box to come up with our shortcut. Nth root of x to the k is x to a. I know it's a division. We just have to be clear which one goes on top. K over n. We buy it? See if you can squeeze k over n in that box. It's the same as the 21 divided by 3. So it says put lots of stars around this formula. Go ahead and do that. Lots of stars. That's an important one for us. The one that we just filled in the blank for, x to the k over n. And so, for example, if you see the 5th root of x to the 8th, that's really x to the, what's the fraction? 8 over 5, okay? Even though 5 doesn't go into 8 evenly, 8 over 5 is an acceptable answer. It wasn't in the lesson we just finished, but now it is. It's okay, just 8 over 5. All right, so I've got these silly little mnemonic devices that I came up with to figure out how to go between radical form and exponential form. So we know that of the 5 and the 8, which one is called the index? The 5. And that 5 ends up going in the denominator of the fraction, yes? And so I'm thinking of this fraction as being like a boat, and there's an above deck, and then there's the fraction line, and then there's a below deck. We kind of see that analogy. So I say that the index goes below deck. The index goes below deck, goes underneath. And then flowers grow upwards and powers go up. And so I'm thinking of that power of 8, x to the 8th power, going up in the fraction. Silly, may or may not help you. Ultimately, you just need to be able to know which one goes on top and which one goes on the bottom. So let's try these two examples here. Number 3 says rewrite this in exponential form. It is currently in radical form, and we want exponential form. So first thing, that negative 2y gets copied in parentheses, and we got to put a power up there. That power is going to involve both 11 and 13. One vote for 13 over 11. Other votes? Okay. There's really only one way to get it wrong, and that's to put 11 over 13. Just got to make sure you don't put that. Okay, and then I want you to go the other direction too. Take something that is in exponential form, like x to the 2/7, and rewrite it as a radical. Equals radical. Copy an x. The 2 and the 7 are going into certain spots. Which one is the index? Is the 7. Where does that 2 go? It is x to the power of 2, right? So just have to be able to go both directions. Okay, so let's take a look at number 5. It says evaluate the following by first rewriting each in radical form. First one is 64 to the 1/2 power. Now we're going to type this on the calculator in just a second, but not right now. 64 to the 1/2 power. Okay, so first thing I'm going to do is say, okay, if I see a fraction power, I know that there is a radical lurking around. Where does the 1 go? Is it the index or the power? It's the power, so I'm putting a 1 right up on the power, which means the index is what? 2. So this problem is really just asking for the square root of 64, which is 8. Super. Possibly for the first time in your life, you are seeing a fraction power. And it turns out that that 1/2 as a power just means square root. So 64 to the 1/2 just means square root of 64. It's 8. In part B, it's the same idea, except this one is going to be the square root of negative 64. Yeah? What is the square root of negative 64? What is it? Is it negative 8? Yeah, there isn't, at least not in the list of real numbers. Like negative 8 seems reasonable, but if you do negative 8 times negative 8, we get positive 64, and we wanted negative 64. So our answer at this moment is not real. Some of you guys have seen another set of numbers that includes the real numbers. Anybody know the name of that other set of numbers? You may have seen in some other math class. The letter I in a math class. Imaginaries or complex numbers. We will talk about them later this semester. At the moment, we don't have them. Our answer here is not real. Okay, part C. Part C looks an awful lot like part B. Are they the same? Where does that negative go? Outside. It's the same distinction we've been making. Powers do not reach very far. So the thing that is touching the power here is just the 64. This is just saying find the square root of 64 and then slap a negative in front of it. So what's the answer here? Negative 8 is good. Perfectly real, perfectly well defined. Different from part B. Okay, in number 6, it talks about doing one problem in 2 ways. We'll just take a look at it. 8 to the 2/3. Brand new power, 2/3 as a power just means there's a radical. Is that 2 the index or the power? That's going to be the power, and the 3 is the index. So this is really cube root of 8 to the power of 2. Yeah? That's the cube root of 64, which is 4. All well and good. I'm going to choose, just to see what happens, to put this power outside as opposed to here where it was inside. See the difference? So let's see what happens if we put it outside. It's not clear that I can do that, but let's try. This one would say the cube root of 8 and then square it after instead of squaring the 8 first. What is the cube root of 8? It's 2. And then that squared is still hanging out, and 2 squared is 4. And did we get the same thing? The answer is yes. And so in this case, the numbers are small enough that it hardly matters. But in some cases, the numbers are going to be bigger, and you're going to want to pick the one that's easier. Do you see which one ended up with smaller numbers? First way or second way? Second way had smaller numbers. Not that 64 is intimidating in the first problem, but we didn't have anything nearly that big in the next problem. And so in number 7, as we've just seen, it doesn't matter whether you put the power inside the radical or outside. If you are doing a numerical calculation, keeping in mind on the next quest, you will not have a calculator in your hand. You want to put that power on the outside every time, okay? You'll have an opportunity to practice that in the activity next time. Okay, so what we saw up above was this thing that you just put the power on top and the index on the bottom. What we have just seen is that it's also perfectly okay to do that, where the power goes at the end of the problem, outside of the whole thing, okay? All right, number 9, let's complicate things further by throwing a negative into the exponent. Dealing with the negative exponent is generally a good first step. Okay, everything's written out there, but I want to feel like I'm doing something, so let's just try this one down here. So my suggestion, when you see a negative power, is you handle the negative piece first. We saw last time that a negative exponent really means 1 over, and you make the exponent positive. Do you guys remember this? It's from before the test. That's essentially our definition for a negative exponent. It means 1 over, and you make the exponent positive. Okay, so I've handled the negative. Now we're going to handle the fraction. The fact that there's a fraction means what is lurking. Fraction power means what is going on behind the scenes. Is a radical of some kind. Fraction now just means radical. 16 is here. The 4, where does the 4 go? It's the index. How about the 3? It's the power. Now we have 2 choices for where we put this 3. You can do this, or you can do this. Yeah? Again, you don't have a calculator. Anybody happen to know what 16 cubed is? Nope. Is it on the sheet? 16 cubed? Is 16 cubed on the sheet? Nope. So this is not something you'll want to do. I suppose if you're clever, you look at the greens because my greens have a few more cubes. But the idea here is that we want to make our lives easier, so we do the easier thing, which is cube at the end. 1 over 4th root of 16 is nice. What is it? It's 2. And the cube is just hanging out waiting, and it's much more manageable to cube now than it was to cube when it was a 16. 1/8 is our answer there. Questions on that one? Okay, so the last example for the day is on the next page. It's like this, but it's going to have variables in it, not just numbers. Okay, this is about as hard as it gets in terms of these fraction exponents. So here we go, 2 different methods to do this problem. We're just gonna, I won't write it all out, it's typed up, so I'll just do some pointing. Here's the original problem, 35x to the -1/2 divided by 20x cubed, the whole thing to the -2. This is like the culminating problem of everything we've done since the test material. This is gonna apply a lot of our different rules, not just from today, but from previous classes too. Okay, couple of options. First option is to take the thing that's inside and simplify as much as you can before you deal with that -2 outside. So for example, 35 and 20, what number goes into both? 5 goes into both. So if we take out the 5, that becomes a 7. Take out the 5, that becomes a 4. Yeah? If you see a negative exponent, you could do 1 over. You could also think of motion. If it's a negative exponent in the numerator, you move it to the denominator and make it positive. If it was negative in the denominator, move it to the numerator and make it positive. Where does this guy go? Downstairs and becomes x to the f. There it is. X cubed had no reason to go anywhere. It's still down in the bottom. Okay. Only the negative exponents move. What do we do with powers? We add them together, right? So that's 3.5. Let's write it as an improper fraction, 7/2. Next, there's a -2 on the outside. We know that that -2 comes in and hits everybody on the inside. So that's all written here. 7 to the -2, 4 to the -2, x to the 7/2, all to the -2. And then what do we do with powers like that? What's that? We're going to do some flipping in a minute, but first, what do we do with those 2 powers? Multiply, right? That's one of our properties. So we multiply those 2 powers and we get just -7. And now I see all these negative exponents and I say, okay, I can just move any negative exponent and make it positive. So where does the 7 to the -2 go? Goes downstairs, becomes 7 to the +2. 4 to the -2, x to the -7, they both move upstairs and become positive. 4 squared is 16, x to the 7th, 7 squared is 49. It is hard. I don't know what else to say, gang. These are hard problems. There is another alternative. Just looking at how much space it takes up, it looks slightly shorter, but still not easy. So I think we're out of time in a few seconds. So I'm going to say, take a look at that alternative method. And if you like that better, go with it. And we'll pick up here next time. I didn't check homework today. I'll come around and get it. If you can stick around, I'll take a look now. But if you have to leave, I'll check it next time.